My name is Alexi Switz, and I am a graduate student at Florida International University, working in the Prasad Lab for Materials Research underneath Dr. Anamika Prasad. And today I will be talking about the in-house electrospinning platform we have developed. So first we'll just start off with a simple diagram of our electrospinning setup. You can see there is the pump that's connected to the needle tip, which is connected to the power source, which is also connected to the collector, and it's all sealed inside of an environment chamber. So now that we've gone through the diagram of the electrospinning setup, let's take a look at the actual physical in-house electrospinning setup. First here, I am showing you the lower voltage power source. We use this to actually go ahead and ground the collector plate. This lower voltage power source that we use to ground, as well as the high voltage power source that we use to charge the needle tip, is all stored underneath our electrospinning chamber. Then this here is our high voltage power source, which you can see connects back, and via alligator clips we have connected to our needle tip. This is what provides approximately 15 to 20 kilovolts of electricity to our needle tip. Right here, I'm showing the pump that we use to push the polymer solution out of the syringe. The pump is connected via tubing to the needle tip, which is charged with those 15 to 20 kilovolts of electricity. And then inside here, you can see kind of the enclosed electrospinning space, which the needle tip is inside of. Inside of this space, we also have our collector. We have 3 different types of collectors that we use, but today we'll be talking about the flat plate collector. You can see it's sitting on a stand to have it be at the proper height with the needle tip, and this flat plate collector is grounded. This flat plate collector is grounded using the low voltage power source that you saw earlier underneath the entire electrospinning setup. Another thing you'll notice inside of this setup is there's tons of polymer solution kind of all throughout. When the polymer solution sets and dries, sometimes it can be a little hard to clean up. On this electrospinning setup, we have spun and can spin a variety of solutions, but today we'll be using a cellulose acetate dissolved in acetone solution. We create this solution by first weighing out the cellulose acetate and acetone. We then combine them together in a beaker and allow it to stir for about 30 minutes. This next clip here is going to show a zoomed in visual of the Taylor cone. The Taylor cone comes out of the needle tip, and this is where the fibers are actually beginning their formation. The fiber is then stretched and elongated from this Taylor cone due to the electrical gradient and electrical forces present. Once the fiber reaches the collector plate, it is deposited and turns into a solid fiber. The electric field has electrical bending instability, which creates thinning of the fibers. Various parameters such as voltage gradient between the needle tip to grounded collector plate, the distance between the needle tip and collector plate, the fluid flow rate of the polymer solution, and the type of polymer solution can be altered to change the orientation and diameter of the fibers. This next clip here shows the initial formation of the Taylor cone from the needle tip. You can see that once the polymer solution starts flowing out of the needle tip, the Taylor cone is formed, and a tiny fiber can be initially seen extending from this Taylor cone. This fiber is then stretched and deposited onto the collector plate like we talked about earlier. While the video footage shown here displays the flat plate collector, which allows us to create randomized mats, we do have 2 other collectors that we can use on this electrospinning setup. The rotating drum collector, which allows us to create aligned nanofibers, and the spinneret collector, which is an acrylic plate with a grounded metal rod in the center, which allows us to create coiled nanofibers. This in-house electrospinning setup that we have designed and created is affordable and relatively easy to replicate. However, we do sometimes have issues, which is expected with research and our Taylor cone formation. In the next couple clips, you'll see some mishaps or Taylor cones that you may not expect to see coming from an electrospinning setup. When mishaps and mistakes occur in research, It's important to problem solve and find a solution. In our case, for this setup, we typically turn off the voltage, wipe away any additional polymer solution that's stuck to the needle tip collector and is causing the improperly shaped Taylor cone. We can then turn the voltage back on and begin electrospinning again. It is incredibly important to keep in mind safety when using an electrospinning setup, as high voltage can be dangerous. These last three images here are optical images edited using image J of cellulose acetate fibers that were spun on this in-house electrospinning setup.